All right, hi everyone. I'm Steve Crusan. I'm from Hudson River Trading. I work on the storage team. This is mainly going to be a talk about DNA3, Lustre 214, and basically Lustre 215, and a little bit of like a comparison between NFS versus Lustre. Obviously, we're a trading firm, so we can't really get into like the specifics of what we're doing. But I mean, if you've worked at a trading firm before, it's pretty similar. You have grid computing and you read a lot of data. Very high level overview. So talk about who is Hudson River Trading, Lustre 214, 215 client server, DNA3, some tooling and metrics gathering that we've developed at HRT and are going to open source. Final thoughts, and then questions and answers. So who is Hudson River Trading? I would describe HRT as a math and science company and probably more of like a software engineering company than a trading firm. I've worked in finance before, and I feel more like this is a high-level software company than it is a trading firm specifically. There's just a lot of software and infrastructure and things happening, and I don't really feel like I'm always dealing with the 90s stereotypical idea of like someone that's sitting in a pit yelling and screaming and things like that, though. So just kind of pull this off a wiki, but HRT is a quantitative trading firm headquartered in New York City, founded in 2002. We're a pretty committed, sponsored open source software in partnership with the community. We host Debian meetups at our location in New York City. Obviously, like I'm allowed to make this talk and talk about our usage with Lustre. So we're pretty committed to open source because we do use a lot of the Linux ecosystem and things like that. So what we have at HRT in relation to Lustre, we have a small but pretty important Lustre installation. So as I said, talk about some of our experiences. So the big thing, Lustre 214 and Lustre 215. I might say 214 accidentally, but I think at this point, we're pretty much running like 215 RC something though. If you check the versions on our systems, it'll say 214 _ some version, but we've been working a lot with WAMPL though. So I think like if we had to go to 215, I would be fairly comfortable because we're kind of at that point. So if I say 214, I mean 215. As for myself and some other people on the team, this isn't our first rodeo with Lustre. So the idea that we'd be running 214 or 215 in production was a little bit scary. And well, we kind of knew what was going to happen though. Not going to foreshadow anything, but probably what the talk is about. Why would we do this, especially at a commercial firm? Well, I mean, someone's got to do it. So when we see presentations from like Stefan Thiel talking about 212, things like that, unfortunately, people need to test some of this stuff. And I'll talk a little about this more, but DNA3 and MDT performance is important to us, though. And and I'll detail this, but some of the other solutions just kind of weren't what we were looking for. But from a high level, we found a couple issues with the 214, 215 code before we went into production. And this was just by purposely running horrible things that we know are horrible on purpose on the file system before we have user data on it. That could be, spawning many instances of MD test from, our compute grid to different directories and just trying to create, 500 million directories and then filling up with 500 million files all concurrently. Not something you'd see in production, but the DNA3 code, it was very new, so we had to exercise the hot path as much as possible. At the same time, intermix IOR and NFIO. Just because with the new DNA3 code, I mean, it's similar to DNA1, so there's going to be a remote directory relationship between MDTs, but at the scale we were looking for, we would rather hit it as hard as possible. We found a bunch of issues, but I would say that we could have done a better job from testing on our end before we put it in production, but nobody's perfect, and sometimes you can't find everything. Honestly, most of the trouble was from DNA3, the MDT to MDT communications. I think it's called MDT out. I never remember all of this stuff, but basically there's transaction logs that happen between all the metadata targets based on the remote directory relationships. But even under high loads in production, we didn't really have a lot of failovers. Most of the failovers were caused by bugs and some HA management tooling, which is outside the Lustre core. However, when we did need to fix things, because then we had to do failovers, and that's when we started to have a little bit more trouble. So big reasons for DNA3. HRT has traditionally been an NFS shop, and all of our NFS systems, whatever they are, all have pretty transparent distributed metadata performance though. So the application doesn't make dir. It's if you have a scale-out NFS system that has say 10 nodes in it, let's say like a Isilon or something like that. That's a fairly common thing that people are aware of. The maker will put different inodes and things like that on different nodes though, so it's kind of spread across the system to get better performance. We started out with like a Lustre POC a while ago, and the first thing we were told when I asked this question was, well, you can do DNA1, and my response is I'm not handcrafting directory trees. I know how it works, and it's probably not going to be too much of a problem, but I mean, our codes are not going to be Lustre aware. They're not going to be NFS aware. Besides, like, is it S3 or is that a POSIX interface? And the other thing is, if we if we use DNA1, it doesn't solve like spreading the metadata load out. It just kind of, hopefully, however you set it up, kind of shards it in some way, but it doesn't go deep into a single tree. So you kind of pin a user or pin a project onto one MDT, and so you're kind of stuck with that. We're pretty metadata performance sensitive. I think that can be improved because metadata is just not great on any file system, no matter what. But at the same time, this is what we have to work with here. So DNA2, from seeing a lot of presentations about it, doing some reading, I think it's probably makes sense for a large directory that has 150,000 entries in it though, and maybe you stripe across 4 MDTs or something like that. I think that was the scaling limit was 4 MDTs. But basically, it's not something that you would want to set up any sort of inheritance for. I did that on purpose on our POC system, and over like a 3-day period, we filled up all of our MDTs because we just have a lot of directories, and the write amplification of inodes and things like that, and the locking overhead just does not make a lot of sense for doing something like that. But it was more or less, I kind of did it on purpose to get to number 3 when we kind of had a conversation with WAN Cloud. It's like, can make dir just be transparent and put and start placing things on different metadata targets, kind of like in a random fashion, similar to how OSD object allocation works. So we talked about it for a while, and WAN Cloud agreed to do it. And I think that code actually was before that was in the works for a while, though it just never was finished up though. It's based on prioritization and things like that. So I think everyone wanted to do this. It just someone had to finish it up. So DNA3. Talk about a little bit in practice. I'm very happy that basically instead of having like 15 slides about all these different tunables, you just run one command and it's pretty much it. So if anyone's familiar with DNA1, I would say DNA3 is similar to DNA1, but it's just automatic though. So your applications have no idea what Lustre is. They just you just set an admin policy on like a top level directory, and it's inherited throughout everything else, and just make dir either puts another subdirectory on a different MDT or the same one, etc. So you have to look at the man page. I'm not going to read through this too much, but basically you set a policy on a top level directory, and then there's a concept of inheritance similar to what you see with like LFS set stripe. So this is set dir stripe, but same concept. The big things here are going to be -X, which is going to be inherit space balancing. This is configurable. I personally just set it to -1 because I do want space balancing to happen if there is ever a problem. I might walk that back sometime in the future. And the second thing is max inherit round robin in the depth. So what that means is if you create a top level directory and you set this max inherit round robin depth to 8, you create 8 subdirectories, and at the 8th one, there's a good chance that the code will no longer round robin anymore, and it'll try and set more of a stickiness on a parent directory, so it only creates subdirs under that on the MDT that level 8 was created on though. There's obviously a cost to creating remote directories. So the code tries to be aware of that, and I'll get into that a little bit more. But essentially, you know, between your depth of 0 versus whatever you set here, if you create, you know, 100,000 subdirectories spread across that depth, there should be a very good balance of directories on different MDTs, and then all the inodes for files within there. So example, I did this yesterday. It's really simple, as you can see. I set the inheritance depth to 4. A dump script that went 10 levels deep, created 40 subdirectories within each one. More or less after that ran, show what happens with the directory layout. It looks like there's an imbalance and something is wrong here, but if we think about how the depth works for a second, so the top level shows that MDT index 1 has over 300. The rest are at a smaller amount. But if we go through each directory level, everything is pretty balanced until we get to the bottom, which is the bottom of the depth. And I'll show that in the next slide. So you'll have to learn the LFS get dir stripe commands a little bit. There's a -D, there's a -D that shows like the default layout. If you remove the -D, it'll show you the MDT it's on though. You kind of have to use both. I guess feedback for WAM Cloud is it would be great if there was an option that just showed all this stuff. I think my fingers get tired of having to type the same command twice. But if we notice here, it's hard for me to see because it's a Zoom thing. But the further we get down the tree, you'll notice the LMV max inherit round robin. It de-increments with every level. So when you get to level 0, basically, there's no more round robining, and then it's going to be space balancing. So, oops, what did I do? And as for why it seemed like we picked most directories on MDT index 1, you'll notice that the space balancing kicked in though. So on this test system though, MDT index 1 had less space usage on it. So it tries to do the right thing here. So what we do in production, I believe this is true for all 215 file systems. If you're running if you're running 215 server side when you mount MDT 0, but the space balancing is automatically enabled, and the max inheritance depth is set to 3. I think this is if you already have an existing file system, you upgrade to 215. I would kind of evaluate this and see what happens first and don't play around with it. Just kind of let space balancing do its thing unless you're performance sensitive. If you actually want to force round robin, that's similar to the other layout QoS round robin command that I'm sure you've seen before to kind of change how the OST object creation is handled. For us, we set our directory depth to 8. How I got to that number, I scanned some of our other file systems and it seemed like the right thing to do. The data sets that we do put on these file systems, they don't typically go deeper than that. So it seemed like a good choice for us, and you know, 99% of the time it was okay. So I'll talk about some pitfalls the next slide, but I guess the main thing I ask myself sometimes is why not just set the max round robin inheritance to -1, so that basically always round robin unless there's a space imbalance problem where the QoS threshold round robin has to kick in. And if I had to do it again, maybe if I was, you know, seeing someone else do it in production and things like that, I might consider that. I think it's something that WAM Cloud can probably provide some guidance for. I think that there's some performance concerns about always round robining and always doing remote directories, but I think it's something that we should, you know, can be talked about in the future. So kind of tips and tricks. Personally, I'd set the max inherent round robin deeper than you think it should be. Unless you have a very small number of directories or something like that, you should normalize things over time. And if you're performance sensitive, we are for metadata. The space balancing does not know anything about performance or doesn't care about it though. So what you'll find is that if space balancing kicks in because you didn't set your round robining deep enough, then all of a sudden you start pinning really hot directories deep into a tree to a single metadata target. Maybe that's okay if you have, one or two MDTs though, because by definition, you're only going to be able to pin thing on one or two MDTs. But if you take the Oak Ridge slide from the last presentation, they have 40 metadata 40 MDSs. So you would prefer to spread the load across all 40 of those systems in some way. Also, make your MDTs bigger than what you think you need, so that space balancing isn't as important to you. I like it. And again, the last presentation had 10 petabytes of metadata though. But I mean, even 10 to 20 terabytes of extra metadata that you can take out of for data storage, that's not really that much for data, and that makes a huge difference for metadata. So make your MDTs larger so you don't care as much about balancing. As everyone knows, if you fill up an MDT, it's going to take a lot longer than it does to fill up 10 terabytes of storage. Obviously, test this out on your own. I found some really weird issues when we first started using this, and I think I'll talk about this a little bit more. But we do find some weird corner cases though. So obviously, test to make sure it works for you. The round robin threshold and the depth and all that. It's something that the admin kind of has to decide based on their own knowledge of their file systems. Everyone's file system is a little bit different, so it's definitely tested out on your own. It's pretty simple to make it work, and like I said, it just kind of works. I ran, I think, 3 total commands on our file system, and that was the amount of tuning I've done for the most part. So that was kind of the goal of this, anyways. Goes without saying, make sure you run in 215 LTS. If you want to be a cowboy, I'm not wearing my hat today, but then don't do that. Then you don't have to run LTS, but I would suggest waiting, a little bit longer. So how is D&E working out for us? Of our hundreds of millions of files, which it is what it is, for the most part, we're very balanced across all of our MDTs, 1% to 2% difference. Between the time of creating this presentation and actually presenting it, we've hit some semi-weird issues with space balancing. I think part of it can be described as potentially directories, going below a certain level, and part of it can be described as an internal Lustre heuristic that kind of sets a stickiness based on the overall directory depth outside of what the admin sets. I talk about it a little bit later down in the slide. Our MDT performance mostly scales with the number of MDTs. So if you have 10 MDTs in each, if you have 10 MDSs and each MDS can do 100,000 get adders, then 1 million get adders is easily obtainable. And that scales with all the other metadata operations that you typically see. So as far as I'm concerned, round robining and kind of, I don't want to say sharding, but sharding or spreading the load across more MDSs is more important to me than specifically balancing. And I think, my experience with this so far is that random seems to be better than like specifically trying to space balance, but this is just, my first rodeo with DNE3, so we'll see. But again, the extent of our DNE3 tuning was three or four alpha set strike commands. That's it. So talking about the strange issue, there's a commit message. I'm not going to click on that link and read it out for you out loud. More or less, the Lustre code assigns a weighting to the overall depth of a directory in the context of the root of your file system. And that's semi outside of what user admin set. So the LFS set dir stripe, that's a part of it, but there's also an internal Lustre heuristic that kind of sometimes makes decisions on, oh, this is too deep in the tree. Maybe we shouldn't round robin it though. See the full commit message though for exactly for that. I'm not gonna go into it too deeply, but more or less, this just happened, a week or two ago. We had a user that I think was at the one level above the bottom, meaning they still should be doing round robin placement, and the code decided that even though it was within the realm of round robining, it decided to just kind of stick 98% of the directories all on the same MDT. And it just so happened that the user code created some subdirectories below that, all on the same MDT because of the stickiness, and then created like 30 million files. And hey, I'm a user, I got to stat everything. So what happened is, actually, it's on the next slide, but so more or less we pinned, and there's not many cases of this happening, but this was just a really interesting one. But we pinned all the metadata IOPS to a single MDT, and eventually I think this caused our first or second actual failover due to load on the file system in like 6 months. Because it absolutely pounded this single metadata target. So what you can do is, again, I already mentioned the round robin threshold. I'm actually tempted to set it really high, but I'm trying to be a little bit conservative here just because there's not a lot of things out here. Regardless, I think the heuristics is slightly counterintuitive. I understand the reasoning why, but I would say that it was a foot gun only because, you know, maybe there's some performance gains by not making remote directories deep into a tree. But what this did is just pinned everything to the same MDT. So what performance, you know, we lost more performance even though it should have round robined. Is what it is, but, you know, we'll get through it. As I said, pegged all the metadata IOPS to a single MDT. I'll be submitting an RFP. Maybe it won't get accepted, but to at least be able to disable the heuristics. Obviously, it puts more of the burden on you as an administrator, but I think that's slightly acceptable just because when I was looking at the issue, you know, a week or two ago, I was like, why did this happen like this? And then, you know, went back and forth and found the problem. All right, so the bug list. There's more than this, but these are the main ones that we kind of noticed. I'm not going to read through all these. This presentation will be posted on the internet though, so you can click on things afterwards. But I think if you look at, like, if you search the JIRA for like DNE3 or failover or something like that, these will probably show up. Essentially, after we went into production, I don't think we actually had any true DNE3 related issues. It was all about the MDT out logging as well as the recovery. So that's just, unfortunately, hitting these bugs happened at the worst times. I guess I can just talk a little bit about them. Like the first one's kind of interesting because what I just talked about earlier about causing a failover because we pinned, you know, many hundreds of thousands of metadata IOPS in a single MDT. When the failover happened, for whatever reason, more or less, once the metadata target failed over, we noticed that some of our other MDTs in the file system were waiting on each other. So it was basically like a directed acyclic graph of death, and nothing was going to happen. So yeah, that was probably the most interesting one. We've had some other ones where failovers work, but they just, you know, evict all the clients though. So I don't know if I'd call that working, but it was fairly destructive. And some of the stuff we found before we went into production though. So, you know, it is what it is. Summary of the bugs. Again, mostly MDT to MDT recovery and log issues. Our metadata intensive codes put a lot of the tested code in hot path though. So this is kind of expected, you know, I knew it was going to happen, but, you know, we got to do it. I don't really have a lot of experience with the more complicated DNE style failover with the multiple MDTs though, so it's certainly a learning experience. Regardless of all this, WAM Cloud identified these issues really quickly when we did, you know, submit bugs, etc. So, and they usually had patches pretty quickly. In fact, you know, there were certain times where we submitted something and they said, yeah, this, we knew about this, but it was so incredibly rare that, you know, it's surprising that it happened, but it is what it is. Some of these issues sound like they're really severe, but if I tally the overall amount of like downtime, when I say downtime, it's like the file system was just hung or offline for like 30 minutes. It really wasn't that much time. And again, we're running on the bleeding edge here though, so I still have a job. So it wasn't that bad. It was just you know, it's just life in the fast lane. So now the less interesting things: monitoring and tooling. How much time I got? Oh God, I gotta hurry up a little bit.
You have about a few minutes.
Okay. Let me just rip through this. HRT is a Prometheus shop. Everything is Prometheus based. We have a Lustre exporter that we wrote ourselves that runs on all of our clients and servers. So we collect data from every single system that has Lustre mounted, whether it be a client or a server. Powers all our dashboards. You all have seen dashboards. Don't care about that. We also use Prometheus Alert Manager though. So any data we collect, we also can use it for alerting purposes though. So obviously we alert for OST, MDT, space, and IDO imbalances. We collect the import states from all the clients, and if they're not a certain integer number, which is going to be idle or full, we alert on that after a while. Fill rates, we black box IO testing, the stupid LS tests. You would think it's dumb, but it actually it does show signs of problems. Let's see. We also run a Lustre REST API on all of our servers. So I'm not going to really read through all this stuff, but basically, all of a sudden we can create extra tools that just, connect from a client, and you can get all the quotas in the file system. You can get like an LTOP type tool for metadata, for data, things like that. Why did I write it, not just fix LTOP or start using LTOP? I don't know. I just wanted to annoy my coworker, and not invented here is apparently a thing for ex-DOE people. But also open files, things like that, local operations. So yeah, I expect we're going to be open sourcing all these tools probably within the next couple of months. I just haven't had time to do it. So final thoughts, 214, 215, DNE3 and all that. So there's a lot of promise. It definitely raised the bar for Lustre metadata performance, especially if you have really good sharding. I'd wait till 215.2.3 unless you're a cowboy. There's still some unresolved bugs. I won't read through it. But generally, I think we're in pretty good shape. I'll just say that MDTs versus OSTs are isolated. MDTs are not. These kind of new communication fabrics are very complex. Lustre versus NFS. I'll just skip through things. I guess from our perspective, we have a lot of NFS experience, but there's some hidden costs of Lustre. With Flash being more affordable, Lustre and GPFS, or before Flash became more affordable, Lustre and GPFS could easily beat most NFS-based systems. Not really true anymore, though, so the gap, I think, is a little bit closed. And until DNE3, more or less all of our NFS systems that we have in-house could easily beat our Lustre systems. The only way that Lustre would get close is we'd have to put some contrived MD testing together where you either create a Stripe directory or you pre-create directories via DNE1. And our NFS systems have had the distributed metadata out of the box. So regardless, I think from a higher performance ceiling standpoint, Lustre is better, but I think that some of the quality of life things could be improved a little bit. How could Lustre improve? I'm not going to rant too much, but I feel like disabling the page cache because you have SSDs is an anti-pattern. I understand it's not a Lustre problem, it's a Linux kernel problem, but that seems like something that should be fixed. Some of our NFS systems have no problem with this whatsoever, and we get great cache hits and do a lot of throughput. Peter already mentioned this in the update, but adding and removing from the file system is really cumbersome. I realize most people on this call probably don't do that because of this reason, but from more of an enterprise standpoint, if I wanted to add another petabyte or something like that, and we already had an existing, for example, 2 petabyte system, there would be a huge performance. There would be a huge change in performance, especially if we're relying on top-end performance, especially for metadata. For data, you can probably get away with it. But for metadata, especially if you really rely on the top-end aggregate and sharding or randomize as much as possible, it does cause a huge issue. I'll say that. DNE3 should be a little bit more automatic. Personally, I'd love it if at the root of the file system is already set up and you never do anything with it again. If admins want to tune it themselves, go for it, but I'd rather it's always randomized, and normally it does the right thing if need be, though. The bug tooling is really rough. We all know this. So some of this sounded overly negative or harsh, but I mean, our experience has been pretty positive with Lustre. Few other systems can kind of do anything close to Lustre, and it's going to be understandable that there's going to be bumps in the road, especially running 215 before it's even LTS. I get it. So Lustre gets our seal approval. Thanks to everyone at Lamp Cloud, really responsive and fix things really quickly. These are really hard problems to solve, though, so we really appreciate the work there. Thanks to my coworker to Hudson River Trading, and of course our users for being understanding sometimes. questions, and obviously the obligatory we're hiring.
Thanks, Steve. Any questions for Steve? Please post them in the platform chat or raise your hand and the moderator can unmute you. And I think we have time for a couple, so I'll throw you one, Steve. So I'm going to, based on your presentation, it sounds like where some people might think maybe the IO workload needs to be reworked, you guys took the concept that you have whatever workload you have and you need to make a storage system that works for that. Is that true?
That's correct, but we do understand that you need to fix some of your metadata things as well, though, and there are efforts to do that, but at the same time, if we stop thinking about user workloads for a second, at one time last week I was deleting like 40,000 files per second, syncing data from a different file system, doing production IO, all these things in aggregate all at the same time. And we're doing a ton of metadata operation on all of our MDTs though, and it's not just user workloads too. Like, so if you need to be productive and do a lot of things at once, like you really want to have your performance kind of like sharded out or spread out as much as possible. But the other thing is, I mean, I would say that from a commercial standpoint, everyone is aware of good and bad IO, especially, but fixing that is another thing though. So we're not an MPI shop. We're not running MPIO, Romeo, things like that though. So people just say we need to do IO and whatever, fix the problem or find a storage system that does it. Our NFS systems kind of set the bar though. So when we started working with Lustre, we said, if we need Lustre to do this, or Lustre would have a very limited role where it's only for like bandwidth and that's it. And at that point, we can find an NFS system that does pretty good for bandwidth.